Welcome to this explainer. Okay, today we are tackling something absolutely massive. Honestly, it might just be the single biggest hurdle we have left in the development of artificial intelligence. We're diving into a groundbreaking July 2026 paper by researchers Gabriel Kailai-Meliu, Armand Cohan, and their team at Yale. What they've done here is map out the next great frontier of AI. Now, I know a term like metacognition sounds deeply philosophical, but trust me, it has incredibly practical, real-world implications for the tech we rely on every single day.
Here's how we're going to break this down today. First, the Metacognition Foundation. Second, AI's missing cornerstone. Third, measuring AI self-awareness. Fourth, teaching LLMs to reflect. And finally, number 5, the future of smart AI. Let's jump right in.
Starting with Section 1, the Metacognition Foundation, or thinking about thinking.
Before we can talk about machines, we really need to understand what this uniquely human trait actually is. Metacognition is, in plain English, thinking about your own thinking. It's like having a built-in mirror for your mind. You know that moment when you're working through a problem, you catch yourself making a mistake and you self-correct? Or when someone asks you a question and you instantly just know that you don't know the answer? That right there is metacognition. The authors of this paper highlight that this isn't just a bonus feature, it's a foundational component of true intelligence. It's absolutely crucial for effective learning, complex problem solving, making good decisions, and clear communication. Because without it, intelligence is surprisingly fragile. You might have a million facts memorized, sure, but if you can't evaluate your own understanding of those facts, you're going to get stuck.
Which brings us to Section 2, AI's missing cornerstone and the current limits of LLMs. So, let's look at where we actually stand today. Current large language models have made ridiculous progress across all sorts of diverse, real-world tasks. I mean, they're writing code, summarizing massive documents, passing exams. It's impressive stuff. But there's a huge gap between that and an ideal, truly capable, transparent AI system. Right now, LLMs are phenomenal at predicting patterns and generating text, but they don't actually know what they know. They are completely missing that internal mirror. This is exactly why an AI will confidently hallucinate a completely fake fact. It literally cannot take a step back and say, wait, let me double-check my reasoning on that. To build systems we can actually trust with our lives and businesses, metacognition isn't optional. It has to become a cornerstone of the architecture.
And that leads us straight into Section 3, measuring AI self-awareness, or evaluating the unknown.
This is the million-dollar question the paper explicitly calls out. When, how, or to what extent can LLMs exhibit or be endowed with effective metacognitive abilities? It's a massive, fascinating mystery. We know we want AI to reflect on its own output, but can a system that was fundamentally built just to predict the next word in a sentence actually be taught to do that? And honestly, even if we figure out a way to do it, how on earth do we measure it? How exactly do you go about quantifying the internal self-doubt of a piece of software? We are truly just beginning to unravel this.
So, how are scientists attacking this problem? Let's unpack the paper's main contribution in Section 4, Teaching LLMs to Reflect, the Emerging Research Landscape.
The Yale team did the scientific community a huge favor here. They built the very first comprehensive taxonomy of this whole emerging field. Basically, they took all these scattered recent advancements and categorized them into clear focus areas. First up, you need methods and benchmarks, just to measure if any metacognition is even happening. Then, you need techniques to elicit it. How do you prompt the AI to actually use its internal mirror? After that, you need strategies to actively improve those abilities during training. And finally, you have the applications, taking these findings and plugging them into real-world scenarios.
Think of it as a really logical three-step journey. Step 1 is evaluate and measure. You obviously can't improve what you can't measure, right? So researchers are designing strict benchmarks to test for self-awareness. Step 2 is elicit and improve. Once you've got a baseline, you develop specific engineering techniques to polish that metacognitive mirror. And then step 3 is apply. This is where the rubber meets the road. This is taking these brand new reflective AI models and using them to seriously advance fundamental AI capabilities in everyday tools.
Which perfectly sets up our final segment, Section 5, the future of smart AI, looking at open questions and opportunities.
So what is the ultimate so what for you and me? The main objective of this whole taxonomy and all the intense work being cataloged by these researchers is to dramatically advance the fundamental capabilities, reliability, and intelligence of AI systems. Think about it. If you've got an AI assisting a doctor with a medical diagnosis or helping a lawyer sift through complex case law, you need it to be bulletproof. You need an AI that can pause and say, actually, I'm not 100% sure about this, or let me reevaluate my logic. Giving LLMs the power of metacognition is quite literally the key to unlocking that kind of deep, trustworthy reliability.
But look, we have to be realistic. The journey is really just getting started. The authors make it very clear that the road ahead is packed with immense, ongoing technical challenges. There are still major, unsolved, open questions about the fundamental limits of these models. But the flip side is that there are incredibly promising directions for future work. The entire goal of publishing this paper was to stimulate meaningful research, to get scientists talking, and to provide a totally organized repository of knowledge to help push the boundaries of what AI can actually do.
And as we wrap up this explainer, we are left with a pretty profound question to chew on. Will artificial intelligence ever truly be able to think about its own thinking? We've got the map, we're building the benchmarks, and we are categorizing the techniques. But whether we can actually cross that final threshold, moving from really advanced pattern recognition to genuine, self-reflective intelligence, is without a doubt the grand challenge of our time. It is going to be a wild space to watch, and whatever happens next is going to completely reshape our relationship with technology. Thanks for joining me on this deep dive.